What's up? I'm Vin, and today I want to show how to use the angle sum formulas to find the exact value of trig expressions. So here's the two questions we're going to go through, and let's get started. So first up here we have cosine of 105 degrees, and we're going to use the cosine angle sum formula since we're dealing with cosine. And the process for these questions is you have to think of two angles that have a sum of 105 degrees. Now, when I look at this, I try out the significant angles, and I'm thinking of 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, because these are the values that when we plug into cosine, we have exact values for. And when you look at this list, you think which two of these, when you add them together, would give you 105 degrees, and that's going to be 60 and 45. Now, it doesn't matter which one you designated as A or B, but just for the sake of getting started, let's say A is equal to 45 degrees, and we'll say angle B is equal to 60 degrees. Because now what we could say is that cosine of 105 degrees is equal to, and now we just use the formula. We have cosine of angle A, which is 45 degrees, times cosine of angle B is 60 degrees, and then minus sine of angle A is 45 degrees, times sine of angle B is 60 degrees. And when we go forward with this, we just have to know cosine of 45 degrees is equal to square root 2 over 2, times cosine of 60 degrees is equal to a half, and then we have minus sine of 45 degrees is square root 2 over 2 times sine of 60 degrees is square root 3 over 2. So now we just have to simplify this. Square root 2 times 1 is square root 2. Over 2 times 2 gives us 4. So we're just multiplying the fractions together before we subtract. And then square root 2 times square root 3 is going to give us square root 6. Over 2 times 2 is 4. So then we're just going to write this as one expression. So if we combine this all, we could say cosine of 105 degrees is equal to square root 2 minus square root 6 all over 4. Now, just to be 100% sure we did this correctly, we could write our answer as a fraction. So we have alpha y equals, enter to pull up a fraction, and we said square root of 2 minus the square root of 6 all over 4. So we could type this in here. And then the first question we had was in degrees. So we'll go to mode and we'll switch over to degrees here. And we want to see, is this expression here, this decimal value, equal to cosine of 105 degrees? So we're just going to test this out and notice that we get a match, so our answer checks out. Now, the thought process for this example, the first thing that jumps out at me when I look at this expression, sine of 17 pi over 12, is I think of the angle 17 pi over 12, which is in radians, and I think, well, 17 pi over 12 is less than 24 pi over 12, which is equal to 2 pi, which is equal to 360 degrees. So I know this is going to be a big angle, but it's going to be less than 360 degrees. And then the next thing that jumps out at me is that 17 pi over 12 is equal to pi plus, and pi is equal to 12 pi over 12, so we'd have an extra 5 pi over 12 that we're dealing with. So my first instinct is to set A equal to pi, and then B equal to 5 pi over 12. Now, the problem with this is that if we look at 5 pi over 12, and let's say we convert this to degrees by doing times, and let's just fix this, times 180 degrees over pi, then what we get here, after we do 180 over 12 is 15, 15 times 5 is 75, we have a 75 degree angle. So the thought process is going to extend again to, once again, these angles. We have 0, 30, 45, 60, and then 90 degrees. These are our significant angles. I'm already thinking here that I'm going to somehow include a 30 and 45 degree angle later on. But now let's just go ahead and get started with this. So we have sine of 17 pi over 12, we could say is equal to cosine of angle A is equal to pi radians. And then we have sine of angle B. And then we have plus cosine of angle B is going to give us 5 pi over 12. And then we have sine of angle A is equal to pi radians. And just know, as a side note, sine of pi is equal to 0, and cosine of pi is equal to -1. So this second part here is going to cancel out completely. And right now, this is going to leave us with cosine of pi is -1. We're going to have negative sine 5 pi over 12. Now, we get to this point, and I chose to do it this way to show you that sometimes when you're solving a question, you may temporarily get stuck. But what I'm thinking about at this step here is that, once again, we said that 5 pi over 12 is equal to 75 degrees. This was something that we showed separately before. And what I said to keep in mind here is that 75 degrees could be made up of 30 degrees plus 45 degrees. But now what I could say is that 5 pi over 12 is equal to 30 degrees in radians is pi over 6, plus 45 degrees in radians is pi over 4. So what I'm going to do is I'm going to set new values of a and b. And maybe this time I'll call them alpha and beta so it doesn't match a and b from before. But we'll say alpha is equal to pi over 6, and then beta is equal to pi over 4. So now what we have is we have this expression, negative sine 5 pi over 12, and we're going to run this through the formula once more, that we have the minus on the outside, and then we have cosine of angle A, but in this case angle alpha. So we have cosine of pi over 6 times sine of angle B, and then we have plus cosine of angle B, so we're going to have cosine of beta is pi over 4 times sine of angle A, which was pi over 6. And now we'll just close the brackets so this doesn't collide. And now it's just a matter of simplifying. Cosine of pi over 6 is square root 3 over 2 times sine of pi over 4, same thing as sine of 45 degrees, is square root 2 over 2. And then we have plus cosine of pi over 4 is square root 2 over 2, and then sine of pi over 6, or 30 degrees, is equal to a half. So now let's go ahead and close this out. We have negative sine 5 pi over 12 is equal to, and now we're just going to leave the negative on the outside and fix up the inside. Square root 3 times square root 2 is square root 6 over 4, plus we have square root 2 times 1 is square root 2 over 2 times 2 is 4. So if we want to combine this into a single expression, we could keep the minus on the outside, and then our fraction is going to be square root 6 plus square root 2 over 4. So this allows us to say the full answer here, sine of 17 pi over 12 as a single fraction is equal to negative, we have square root 6 plus square root 2 over 4. But now, once again, just to be 100% sure that we did this right, what we're going to do is we're going to type in the original question and our answer to see that they match. So we just found sine of 17 pi over 12 radians. So we have 17 pi over 12 here like this. And then our fraction, well, first we had a negative on the outside, and now we're going to type in our fraction here using alpha y equals enter. And what we had was square root 6, and then we exit this, plus square root 2. And this was all divided by 4. And notice here that we have an exact match, so our answer checks out.